Hello everyone, welcome to Code and Cosmos, and in this session I will talk about network automation with Ansible, and I will talk about the modules we are going to use to actually perform some tasks related to configuration for network devices, and we call those modules resource modules. So let's see what we have in our agenda, and then maybe we can carry on with our slides there. So I will talk about automation for networks as generic, and then Ansible network automation, why Ansible network automation, and then network resource modules, which is really important, and fact gathering, and then I will demonstrate the fact gathering and usage of resource module. So let's see what we have in our next slide. Okay, so why we need to automate networks, or what is the problem with like manually handling all the complexities or performing the tasks there. So first thing is legacy operational practices. So managing network hasn't changed much for years now, and most of the network engineers are not much into programming, right? And still they are following legacy operational practices, and by legacy operational practices I mean manually doing the SSH onto the device and then performing the tasks there, and then when it comes to validating those tasks, so there is only one option, that is manually, and then logging out of that devices. So next one is no source of truth. So multiple people could be working on same device, and let's say if someone made some changes and others are not aware of that, then they need to go through those changes. They need to find out what were the changes made by the some other person, and that could be really painful task, especially when you're dealing with a lot of network devices in your network. And next one is vendor specific implementations. So most of the vendors have implemented their technology in a way which is really quite specific to them. So if you are a network operator, you could have like maybe Juno switches, Cisco routers or wireless router, and when you want to configure something, then you really need to be aware of their technology there. Next one is configurational drifts. So configurational drifts, okay, so what if two people want to change, two or more people want to change like same attribute? For example, it could be your router ID. So either one of them going to fail if they are going to perform this at the very same time, and so that leaves one of them to not having configuration state to validate actually. So that makes chances of making errors quite high, and that's why it's quite error prone as well. So yeah, so let's move on to next slide and let's see what we have there. Okay, so why Ansible? So what sets Ansible apart for like automation or network automation in our case? So first thing is it's really simple. Some people call it human readable automation, and you don't require any like special coding skills. So all you need to know is how to write playbooks, which is you will be writing in YAML, and that is quite close to what we have in English language here. And then powerful. So despite of being simple, it's really powerful. Basically you could manage workflow orchestration, manage all IT infrastructure, network automation, and then it has agentless architecture, and that means you don't require any different agent running on the device or something like that. So basically it uses SSH or Paramiko based connection, and then perform the tasks, and ultimately the commands got executed on the device. So that's pretty much which sets Ansible apart. And the more you will be using Ansible, the more factors you are going to see that really sets Ansible apart, especially from other tools. Okay, so let's talk about how does network automation different. So most of you must be aware of Linux automation with Ansible as well, and if not, I mean, no worries. So basically, when it comes to Linux or Windows host automation, you could see that here module code is copied to the managed node and executed, and then later on removed once the task got executed. So, but in case of network automation, many devices, they don't support Python yet, and that's why the idea is to basically execute the module code locally on the control node. And when I say control node is the node on which I'm going to install Ansible and ultimately execute my playbook there. So if you're not aware of the terms like manage node, host node, control node, so you might want to go back to some previous videos where I have explained some basics as well. So that would be quite helpful. So that's the pretty much main difference between the Linux and network automation. So let's move on to next slide here. Okay, let's talk about some of the common cases, right? So these are like just to give you an idea about the areas where you could use Ansible, and that could be really provide you great advantage. So you could use Ansible for like backup and restore device configuration, ensure a specific service is present or absent. It could be your VLAN or something like that, and then basically upgrade network device OS, manage firewall access list entries, and again enable or disable specific or particular service there. So there are many more other cases. It's just to give you an idea where you could really use Ansible. So let's move on to next slide. Okay, so Ansible network resource module. So this one is really important. So simplifies and standardize how you manage. Okay, so network device separates configuration into sections such as like interfaces, VLAN, static routes, and basically these are like applied to a network service. So Ansible network resource modules take advantage of this to allow you to configure subsections or resources within the network device configuration. So our resources could be like we have different subsections like static routes, OSPF routes, and then BGP. It could be interfaces, L3 interfaces, L2 interfaces, or lag interfaces, for example. So network next one is different network devices. So there are different network devices, and they all the like vendors, they have specific technologies. So Ansible supports a lot of network devices and consistent experience across different network devices. So when you will be using for example, let's say you will be using a resource module called interfaces here, or L3 interfaces, which is actually used to configure the IP addresses there. So the feel of using that would be same. So these modules are written in such a way that when you are going to write a playbook to configure let's say IP address for Cisco router, or maybe for Junos or Vios, so you are going to use almost same steps there. So I'll show you, I will demonstrate L3 or interfaces resource module, and then we could like explore more. So let's move on to next slide now. Okay, so next part is facts gathering. So before we talk more about the resource module and I demonstrate actually how to use the resource module, so there is another topic which we need to know about is facts gathering. So basically fact gathering is used to collect facts from the network device, and basically these facts could be like basic facts, what sort of device it is and hardware version and all that, what release is it, what flavor is it, and then there could be facts which are specific to resources. For example, There could be facts which are specific to L3 interfaces showing all the IP addresses, interfaces showing the like description or maybe MTU or other values, and then OSPF route and VLAN, etc. So next point is places the facts gathered in the factory keyed by the respective resource name. So basically, when these facts are gathered from the device, these are placed in a key value format in a structured data, so that we could use this later on. And next one is collects a base set of facts from the device. So I just mentioned that there could be some basic information, and that falls into the category of base facts. Allow, enable or disable collection of additional facts. So you could basically select what sort of facts you want to gather. So if your playbook has, if you have mentioned, for example, let's say L3 interfaces in your task or playbook, so that would gather L3 interfaces facts. Otherwise, it won't fetch the L3 interfaces facts there. So I will demonstrate that part so that you could learn in a better way. So let's move on to next slide here. Okay, so you could see how Ansible is fetching an on-box configuration and then basically putting it in a structured format there, that is like key value format. So we could see that we have Ansible facts key here having certain keys like Ansible Net API, which is CLI conf for network CLI connection. Ansible Net gather network resources. So in this part, basically in this example, we are gathering interfaces specific resource module facts, and you could see that basic facts here as well, that is host name, model, serial number, system, version, and then again this is the, sorry, let me go back. So this is the like facts which are specific to a resource module, and that resource module is interfaces here. So you could see the attributes for this particular resource module. So there is like it's enabled, name of the interface, duplex value, there could be like description, for example. So yeah, so let's move on to next slide. Okay, so here is a task in which we are gathering basically base facts and then some resource module specific facts. So resource module is interfaces here. So let me demonstrate and let me show you how to fetch facts specific to a resource and also some basic facts there. Okay, so I'm going to do a manual SSH first, just to show you guys what device I'm using and what sort of running configuration is there. Okay, so let me execute show version. Okay, so this is 118, and you could see other information as well, system type, model, serial number, etc. So to see the running configuration, the command would be show configuration commands. Okay, so this will provide you the running configuration. You could see that there are some interfaces configured having some attributes like description, duplex, hardware ID, etc. And then you could see that SSH is also enabled, which we are going to need if we want to communicate through Ansible, if you want to connect to this device through Ansible. So yeah, please make sure that your SSH service is in running state and then port is right. So next you could see other configuration as well. So I'm going to basically fetch the basic facts here and some of the basic facts, and then again I will be fetching facts specific to interfaces, and L3 interfaces as well, which will provide the IP address. So let me show you my playbook first, and then maybe we can just execute that and see what's there in the output. So here I have as facts. Okay, so basically I will be fetching resource module facts which are specific to interfaces, and L3 interfaces resource module, and then some of the basic facts here. So this is the key if you want to fetch resource module specific facts. So let's try to run this. So let me activate my Ansible first. Okay, so let's run our command. So Ansible playbook for verbose output, and then name of your playbook. So if everything is right with your playbook and your setup, so you should get output similar to this. So you could see okay is it was successful and nothing has changed, nothing has failed or skipped. So if you scroll up, you can see the output, actual output here. So this is quite similar to what I showed you guys in the slide. So we have this key here, Ansible facts, having some of the attributes, Ansible net API CLI conf, as this was network CLI connection based, and then Ansible net gather network resources. So basically it has also like fetched the facts which are specific to L3 interfaces resource module and interfaces resource module. Next one, you could see some of the basic facts here, so which are like host name, model, system, version, and serial number, etc. And here we have Ansible network resources key, which basically has facts which are specific to resource module, and first one is interfaces. So you could see that some of the attributes for this interfaces resource module are like description, duplex, enabled, and speed, and name. So name acts more like a primary key here. So in this case it's Ethernet or ETH3. Similarly for ETH0 we have these attributes. For ETH2 we have these attributes configured, and for ETH1 and then local interface. Next one is L3 interfaces, and attributes which are specific to L3 interfaces are like IP address, and in our case only IPv4 address was configured, and that too through DHCP service. So that's why address is showing as DHCP here. And for ETH1, ETH2, ETH3 we don't have any other L3 specific attribute configured right now. So that's pretty much what we have in fact gathering. I mean, similarly you could gather facts for some other resources as well, like VLANs, lag interfaces, OSPF, static routes, but you have to use or you have to mention the resource module here. So let's go back to the slide and let's see what we have next here. Okay, so next one is our resource modules. So now we are going to continue with resource modules, right? So basically so far we have pulled facts and we have normalized the data, and then we put that like into standardized internal data structure schema, which was like key value based format. And so ultimately now we have on box source of truth, which is really great. But the problem now is that you still need a method to take these key value pair as source and then again convert them back into the specific configuration that a specific device or platform is expecting, right? So platform specific modules now need to be developed to satisfy these new requirements of fact gathering and normalizing activities. So with the resource module, we have structured data as input, and then again resource module acts on it and then provides the commands which are supported by the platform or network device, and then ultimately those commands got executed on the device. So let's move on to next slide. Okay, so for resource module, we provide config as input, and then we also provide state value there. So state is basically what type of operation you want to perform. So there are like 7 states now which are supported, and first one is merged. So the on device configuration will be merged with the provided configuration. So basically, if you want to add something to the configuration, you could use merged, and so it will simply add the configuration onto the device, and then comes the replaced. The on device configuration subsection will be replaced with the provided configuration subsection in the task. So with replace, basically the goal is to replace specific subsections of that resource, and next one is deleted. The configuration of the provided resource will be deleted or defaulted. So with delete, you could simply delete the attributes or that particular resource, or if deletion is not permitted, then you could set that to default. So next one is overridden. The on-device configuration for the resource will be replaced with the provided configuration in the task. So basically it should be like overwritten here. So so when we talk about replaced, it basically acts on specific subsection of the resource, but when we talk about overridden, it will simply override all the configuration which is specific to that resource. So we have to be very careful when using overridden, because by accident we could also override all the configuration, and which could really create some chaos there. So let's move on to next slide. So with latest release, we have introduced new states as well, and these states are gathered, rendered, parsed. So if we talk about gathered, this is pretty much very similar to what we have in fact gathering. So it will simply fetch the facts from the device and display that in structured format, and that would be covered within the gathered key there. Next one is rendered. This renders the provided configuration in the task in the device native format, and Ansible returns this rendered configuration in the rendered key in the result. So for render, the input would be basically it could be your running configuration, and then it will provide the commands which will be equivalent to that particular running configuration. And again, you could perform this like offline. It doesn't establish any connection with the device, right? So it's different than check mode, because it's not establishing any connection with the device. It's just simply converting that running configuration into the commands which are like supported by the platform. Okay, next one is parsed. So Ansible passes the configuration from the running configuration option into the Ansible structured data in the parsed key in the result. So it's quite opposite to rendered. So for this the input would be the running configuration or the commands which are there on the device, and it will provide the structured equivalent of that running configuration. I think I have just I did a mistake. I said for render the input would become running configuration. So basically for the render, the input would be structured configuration, and then the output would be the commands which are supported by the device. But in parsed, the input would be your running configuration from the device, and then it will simply convert that into structured key value format. which we had in like fact gathering as well. So both of these operation, rendered and parsed, they could be performed offline, and there is like no connection will be established with the device. So let's move on to next slide here. Okay, it's time for demo. So let me show you. Okay, so let me open my playbook. So in this video, I'm going to show you guys the 4 basic operations which are merged, replaced, overridden and deleted. And for like gathered, parsed and rendered, I will cover those in my next topic. So for now, it's like 4 basic operations. So let's start with merged. So what I want to do here is I want to basically configure MTU value to 1500, and I want to configure the description as well. And for it to 0, 2 and 3, I'm only configuring the description attribute, and my operation is merged. And even by default, the operation is merged. So even if you are not mentioning state here, it would take operation as merged. So let's try to run this. Okay, you could see it was successful, something has changed and nothing has failed or skipped here. So let's start from the before actually. So before key, so basically it's showing what was there on the device before actually executing our task, what we had in our playbook. So the description was demo, do not save, and there were some other attributes as well. So let's go back to our playbook here. So for it1, I want to configure MTU to 1500. Let's see what it was before configuring this to 1500. So here we have it1, and no MTU was configured here, right? So similarly for this was the actually configuration for the it3 and it0 as well. So our module, our resource module, which is wires interfaces, took this as an input, which is in structured format here, and then act on it and basically processed or formed some commands, which are these, and these commands are supported by WIOS network device, and ultimately these commands got executed there. So after executing these commands, we have also fetched the after config here. So you could see that description is what we had in our task, and for it2 and for it1 the MTU is 1500, and similarly for it3 and it0 we have this description here. So let's try to run this one more time. Okay, so this time we have only before and we don't have any after, and our command list is empty, and that is because it's idempotent. So if you try to run the same playbook again or same task again, so it won't show any difference there, because this was the state which was there on the device already, right? So every operation is idempotent. So like merge, replaced, delete or overridden, all the operations are idempotent here. So let's move on to next operation here, which is replaced. And so basically replace will impact only a subsection of that particular resource. So in this case I'm changing the MTU value to 1300, and I'm keeping the description same here. And so basically it should only affect the it1 and it shouldn't affect the other interfaces here. So let's try to run this. Okay, so with replaced, this was our like before state of configuration. We could see that MTU value for ith1 should be 1500. Yes, here it is. So these are the commands which got formed, and so basically we are deleting ith1 speed and duplex, and then we are setting the MTU to 1300. And why we are deleting speed and duplex, and the reason is in replaced we don't have speed and duplex, so it will just replace that particular subsection with the provided configuration here. So ultimately ith1 should have only MTU and description value. So the description was already, this is configured for support team, that's why there isn't command which are for setting the description. So the idea is to keep it idempotent. So in our after, we could verify the MTU value is 1300, and only name and then description is configured there. So again, just like the merged, it's also idempotent. So I'm going to move on with next operation, which is overridden. So unlike replace, which affects only a subsection of that particular resource, overridden would basically override all the interfaces here. So in this case, it would basically override all the interfaces, resource module specific configuration. And so let's try to run this. Okay, here we are. So yes, it's deleting all the attributes for ith1, ith2, ith0, and so basically we had ith0 and ith3, and for ith0 we had description MTU, for ith3 we had description MTU, and rest of other attributes specific to other interfaces will be deleted here. And in our after, we could see the final configuration. So for ith3 we have description MTU. Enable is just showing the state which is true for ith3. ith0 we could see that MTU is 1500, and for ith2, ith1 we don't have any other attribute configured. Similarly for ith2. So yeah, that's pretty much with overridden. Next one is delete. So in this I'm basically trying to delete ith1, ith2 and ith3. So basically delete operation, it will delete the attributes which are specific to Ethernet 1, 2 and 3. So let's try to run this. So you could see that it's deleting ith3 description and MTU, and this is the final configuration. So that's pretty much with 4 basic operations, and the operations like gathered, rendered and parsed I will cover in next videos, where I will talk about collections. So then I will cover those operations. So let's go back to slide and see if we have something there. So basically Ansible supports EOS, iOS, Cisco, iOS XR, NXOS, WiOS, Junos, and there are other platforms as well on community as well. So So this is the list for some of the modules which you could find and use if you have like Arista US, iOS XR, Junos, and again, I mean, you could basically refer to the documentation, the official documentation. There you could see what other modules are there. So yeah, that's it. That's all I had for this session. And thank you guys. And if you want to reach to me, this is my information. And yes, bye.